Hello everyone. So today we are talking about electron configuration. Your topic is electron configuration. Your goal, I can draw the long and short hand electron configuration for any element. So first off, in order to talk about that, we need to know the background of quantum mechanics and what that is. So, and don't forget, if it is underlined in red, you need to type it out and highlight it and then write the definition for it. So the word you need to highlight in this slide is quantum mechanics, and the definition you need to type out is it describes the motions of subatomic particles and atoms as waves. You also need to know the Heisenberg uncertainty principle, which basically says it is impossible to know exactly both the velocity and the position of a particle at the same time. Because electrons and atoms are always moving, you can calculate how fast they're moving, or you can calculate where their general location is. Okay, so one of the models that we use is the Bohr model, which is very similar to kind of like the solar system, but the difference is that they don't just stay in those circular paths or orbits around the nucleus. Now, each path or orbit does have a fixed energy an electron can have, and that's called an energy level. So the energy levels, you need to make sure to highlight and type that out, is fixed energies an electron can have. So basically, if we look at it kind of like a nucleus, the nucleus is at the bottom of the ladder, and the energy levels are kind of like the steps. The higher an electron is on the energy ladder, the farther away it is from the nucleus. So you also think about it like it takes a lot of energy to climb to the top of the ladder. You only have to have one step to get to the first level above the ladder, but it takes a lot more energy to get to the very top. Well, it's kind of the same with electrons. They have to have a lot of energy to get to the top. To move from one energy level to another, an electron must gain or lose just the right amount of energy. The higher an electron is on the ladder, the farther away it is from the nucleus. You do need to type that first bullet point down. So here you kind of see a model where that middle circle is the nucleus. That's where the protons and neutrons are. Then you have your first energy level, which can hold 2 electrons. The second energy level can hold 8 electrons, and the third energy level can hold 18 electrons. So one thing too that we need to talk about, if we look at this ladder again, I also want you to kind of think about what happens when you drink energy drinks or have tons of sugar. What happens is you get a lot of energy. You're super excited. You can do all this energy. You could run up and down that ladder 20 million times. You're fine. But what happens after you use up that energy? You crash. And then you go back down to the level energy where you like sleep or do whatever you do once you crash. So electrons are kind of the same way. They get this energy, they get really excited, they go up, they move up the ladder, but then once they crash and all their energy is used, they crash back down to what their base energy level is. Okay, so now we're going to talk about electron configuration, which that is the distribution of electrons of an atom or molecule in atomic or molecular orbitals. Or basically, it's just talking about where electrons are located in the atom. You do need to make sure you highlight electron configuration and type out the definition. Okay, so a key concept is the quantum mechanical model determines the allowed energies an electron can have and how likely it is to find that electron in that location. All right, so now we're going to talk about how we write electron configuration. They always have a number in the beginning, just like this blue number 1. They always have a letter after, and then they have an exponent of a certain number. So that first number 1, that it relates to the row number, but it's telling you the shell or which level outside of the nucleus it is. And it could be either 1 through 7. It will never be 8 or higher. It's always just 1 through 7. Okay, the exponent, that's the group number, and that's the number of valence electrons, which we will talk about what those numbers can be, but basically it's the total number of electrons in that specific shell or orbital. And then the S, those are subshells. It can either be S, P, D, or F because there are only 4 subshells. Now, of course, you are probably like, I have no idea what you are talking about right now. That's okay. This you will just see again. And now that we've kind of briefly gone over it, it'll help it make sense when I explain it in deeper detail. Okay, so maximum number of electrons. So the energy level does have a maximum number of electrons. There's only so much room, so only so many electrons can fit. If you are in energy level 1, you can have 2 electrons. Energy level 2 can have up to 8 electrons. 3 can have 18 electrons. 4 can have 32 electrons. And that's it. So now I'm going to go over and fill out a blank periodic table for you guys. And basically, I know we covered this in Chem 1, but I know several people struggle with this. And as long as you get the pattern down, then it's kind of easy to grasp, which is why we're going to go over it again just to refresh you on that pattern. Okay, so today I'm going to fill out the blank periodic table for you. You'll notice this is just like the one you guys are going to be doing on the computer. And, you know, if you would rather print it out and handwrite this and then load that picture and send a picture of it to me, you can. I know that might be hard if you don't have a printer, which is why I also have it to where you could do it on the computer as well. So in Chem 1 we did this, but we stopped about right here. And today I'm going to go on to the very end. I'm actually going to Alright, so first off, we are going to use one color. It doesn't matter the color that you use. And really, on your copy, you do not have to color coordinate. I'm just doing it to help make things a little bit easier. So first off, we know this could just be any color. This section right here is the S. We know that this block is the S. We know that this section right here is the P. We know that this middle section is D, and we know that this lower section is F. All right, so we have our first color. This is the first period or the first line, so this first number is going to be a 1. And then it is in S, so this will be 1S. And it's the first box, so it'll be 1S1. Then over here, we're still in 1. We're still in S, but this is the second box, so it'll be 1S2. All right, that's it for number 1. So let's get another color and do number 2. So this is the second row, so it's going to be a 2. This is still the S section, so it'll be S. It's the first box, so it's a 1. It's 2, still an S, so that'll be 2. So here we are 2, but now we're in the P section, so that will now become a P, and it's the first box, so it'll be 2P1. Then 2P2, 2P3, 2p4, 2p5, 2p6. All right, we'll get our third color. So this is going to be a 3. We're in the S section, so it'll be 3s1, 3s2. Come over here, we're still in 3, so that'll be 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. We will need that color again, so I'm going to set that aside. And now we're going in our 4, so that's 4s1, 4s2. So now we're in the D section, and one thing you need to know about the D section, it is always one step behind whatever's happening at the S. So right here, S is 4, which means this D is going to be a 3, so I'm going to use the color I used for 3, and that'll be 3D1, 3D2, 3D3, 3D4, 3D5, 3D6, 3D7, 3D8, 3D9, 3D10. All right, so now we are back up to 4 to finish the P section. So that'll be 4P1, 4P2, 4P3, 4P4, 4P5, 4P6. Okay, so now we're going to get our fifth color. This will be 5S1, 5S2. Now remember, D is one step behind, so since this is a 5, this is going to be a 4. 4D1, 4D2, 4D3, 4D4, 4D5, 4D6, 4D7, 4D8, and that's the letter D. I know it sounds like I'm saying 48, like the number, but it's 4D8. 4D9, 4D10. Okay, since we're done with the 10, we'll go back to our 5 for the P, so that'll be 5P1, 5P2, 5P3, 5P4, 5P5, 5P6. Okay, so next we'll get our sixth color. This will be 6S1, 6S2. Now, this is where we get to the part we did not cover in Chem 1, and it gets a little finicky. So these two, this is your AC element, and then this is your LA element. So they, in this case, they're going to be right here. And then the rest of this section is down here at the bottom. So this right here, we're going to do just like we did all the others. Since this is a 6, it'll be one step down, so it'll be a 5D1. Okay, so you see where this line jumps down? That's basically showing where these come out. Now the F's is one step behind your D's. So if this is a 5, then that means these F's are going to be a 4. So that'll be a 4F1, 4F2, 4F3, 4F4, 4F5, 4F6, 4F7, 4F8, 4F9, 4F10, 4F11, 4F12, 4F13, 4F14. Okay, now we just finished numbering these just like we did with all the other D's. 5D2, 5D3, 5D4, 5D5, 5D6, 5D7, 5D8, 5D9, 5D10. All right, so we go back up to 6 to finish the P's. So 6P1, 6p2, 6p3, 6p4, 6p5, 6p6. All right, our last color and our last line. So this is going to be 7s1, 7s2. So since this is 7, that means this is going to be one step behind, so that'll be 6d1. Now we jump down here. F is even one more step behind that, so that'll be a 5. So that'll be 5f1, 5f2, 5f3, 5f4, 5f5, 5f6, 5f7, 5f8, 5f9, 5f10, 5f11, 5f12, 5f13, 5f14. Then we just go back and finish off the D's. So 6d2, 6d3, 6d4, 6d5, 66, 67, 68, 69, 6010. Go back up to 7, 7p1, 7p2, 7p3, 7p4, 7p5, 7p6. All right, so here the periodic table is completely filled out. Now I'm going to go over with you guys how to write longhand and how to make it a little easier and do shorthand. So first off, let's do longhand configuration. So basically, you read this like a book. And wherever the element you're looking for, you find that on this periodic table. And you read it like a book and you write out everything that goes up to that element. So I'm going to do some examples of longhand and kind of show you how to do that. And then, because once you get the pattern done, you do it the same way for every single element. All right, so for our first example, let's do iodine. So if you look at a periodic table and find where iodine is, so iodine is right here. So what you're going to do is you're going to read this like a book. Now, you do not have to write down every single box. You only have to put the biggest number. So in this case, 1s1, 1s2. So you'll write down 1s2. Then it'll be 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. So just, even though that 4 is before the 3, just write it just like how it is on the periodic table. So it'll be 4s2, 3d10, 4p6, 5s2, 4d10, 5p5. And we stop at 5p5 because that is where iodine is at. All right, so let's do sodium. Sodium will be a little bit shorter. It is right here in this box. All right, so we start off with 1s2. Then we have 2s2, 2p6, 3s1. Well, that's where sodium is, so that's where we stop. All right, next let's do ER. ER is right here. So this one's going to be a lot longer because it's way down there on the periodic table. So you'll do 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 5d1, 4f11. Okay, it is important that you go ahead and write down that 5d1 because this is after that. All right, so you would do 5d1 and then you would write the 4f11. And that's where we stop because that is where ER is. All right, so RF, that is this element right here. So we will just start from the beginning. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 5d1, 4f14, 5d10, 6p6, 7s2, 6d1, 5f14, 6d2. Okay, so that is how you do your longhand configuration for those elements. All right, so there is a way to make it shorter, and I'm just going to call that shorthand configuration. So what you do with this is you find the noble gas that is right before the element you're looking for. And as a reminder, these elements right here are your noble gases. So the first example, or to kind of explain how I do this, we are going to do calcium, or Ca. If you look at a periodic table, like I don't expect you to have every element where it's located memorized. I'm using a periodic table and I'm looking and I'm seeing which box it would be in. So if I look at a periodic table, Ca is in this box right here, the 4s2 box. All right, so I go backwards until I find the last noble gas. So this is the last noble gas that it passed. I look at a periodic table, 3p6 or whatever's in this box right here is Ar. So in brackets, I put Ar, or argon. It does need to be brackets. If you put parentheses, that is incorrect because brackets mean concentration, or basically it's all summed up into that element. All right, so right here's argon, and then now we just go write everything after that until we get to the element we're looking for. Well, in this case, we're just needing to go to 4s2, so I would just write 4s2, and that is the shorthand for calcium. Okay, let's do another one. Let's do W. So if I look at a periodic table, because I definitely don't have W memorized, it is right here. Okay, so I go backwards. And then I find the last noble gas that it passed, which is 5p6. I look at my periodic table. That is Xe. All right. So now I just write everything after that. So that'll be 6s2, 5d1, 4f14, 5d4. Okay, so I just write everything afterwards, just like we did on the long term, only I start after that noble gas. So it keeps you from having to write everything up in here. All right, the last one we're going to do is Ce, which is 4F1 right here. That first one right there. Okay, so basically what you guys need to know, you need to imagine that these two rows are stuck right where those two black lines are. So technically it's in this row. All right, so we know CE is right here in this box. So you basically go backwards, so it would be like it's right here, go backwards, and that brings us to 5p6. Okay, since that's the last noble gas that it passed. Well, if you look at the periodic table, that is Xe. So we write Xe in the brackets. And then we just write everything afterwards. So that'd be 6s2, 5d1, and then 4f1. Because that is the element we're looking for. So that's all we would need to write. All right, so you guys will need to do this on the next slide. You'll fill out a blank periodic table. You could just format it to make those exponents. If you're not sure how to do that, just ask and I will let you know. And then on the slide after that, you will actually have to type out the longhand and the shorthand configuration for some elements. And again, I know this is tricky, so please ask questions if you're not sure what to do, because I'll be happy to help you one-on-one and get you guys to understand this. Some of y'all may just remember this from Chem 1, but if you don't, feel free to ask. I'll be happy to help.